I bought this capacitor from Apply Street. It cost me 8 Hong Kong dollars. So I want to replace this starting capacitor for this Samyang fan. Now let's take a look on this capacitor's value. We can measure by a multimeter here, this one. Let me show you how to measure a capacitor here. This is a capacitor measurement switch here. Then you can, it's made from China, and so its quality is not very good, but the measurement is good. Now you can see 1.003 mil farad F 1. Now let's take a look on here. Yeah. Now this capacitor has 4 legs, 1, 2, 3, 4, but they are connected. This terminal is the same. They are internal connected, and this one is same. Let me show you. Here is measuring the resistance. Now first, each time you measure resistance, you have to check whether your connection is good. Now it's around these 2 robs, 2.9 ohms. We have to reset it relative to 0, so we can check. Here you can see now 0 ohms, 0 ohm, and here 0 ohm. This means this terminal connects this terminal internally. So let me check here. Now it's open circuit. Actually there's a capacitor between these terminals. Here. And now check the capacitors once again. Here. Now you can see 1 mil F. 1 mil F. Now, okay. Alright. We have to disconnect this capacitor first and then replace this. But you can see this is the horizontal plate to put in this capacitor, but mine is horizontal. I have to cut this out first and then maybe use something to hold this capacitor firmly. Let me check first. Here. Every fan has a starting capacitor for each model. So if you encounter this slow starting problems, you have to replace capacitor to check it if the capacitor is die out. Now here you can see this is the 2 neck but it doesn't matter. I have here, I have 4 necks. I can you know, I can combine them together. That's okay. Now you can see here the arrangement is different, so we have to modify this one. First, I saw this out. If you use a knife, you can't cut it out. You can't cut it out. You use a saw. Okay. Now let me pause one. Now I am doing I hold this capacitor firmly so that I can saw the extension part out. Now it's too hard to damage this. If it is too hard, this one is too hard, it will damage this capacitor, so I will gently to clip it. Now try this, and then give a force. Now here you can see what I'm doing here is maintain the angle. Well, I can smell the plastic. Very bad smell. But it will be done here quickly. So nicely. Here nicely. Okay. Yeah. Now let's check this value again to see whether it is damaged or not, to make sure we use the good capacitor here. Now it's very good value, 1 mF, 1.003 mF. It's very accurate. Now you can see here, this is 1 mF plus and minus 5%. Here you can see here. Now this one you can see. Can you see? Well, there's lost focus. Yeah, you can see clearly. Okay, that's right. Now let me show you how much this capacitor cost. Here you can see here. One mF, 450 VAC. It's power rating for this capacitor. For the electronics, 1 mF is very small one, but it's for the power condition. So 1 mF is a big capacitor. You see, starting capacitor cost Hong Kong dollar, 8 Hong Kong dollar, 8 Hong Kong dollar. Now you can see it, 41. Yeah. Now let me show you how to disconnect this capacitor. We have an iron electronics or iron. Here, this one. Here, I lost my cotton for this one, and I use another rough cotton to replace the regular cotton here, but we have to wet this cotton first. Now here it got wet. Now this cotton get wet so that we can clean this iron firmly and cleanly. Now here I can show you it heat up. Now let's check. See here. Yeah, it's warm enough. Now, let me give you some techniques about using the Now I use this clamp to hold this capacitor firmly so that I can solder here. If you just use this clip, it will too light to hold this capacitor. If I use this iron and metal clip, it will pull by gravity and hold the capacitor firmly. Now let me show you here. Oh. Here, it's firmly okay. Here, let's put some, because I want this wire take out, so I have to solder here. It's very light, so I have to increase the mass here. Now it have a pull, and it's hard to pull out. Here, see. The solder will drop into the frame, so I have to protect my frame first. Here. That's okay. And then let me check the capacitor values first to see whether the capacitor is good or not. Here. Now I'm measuring the good one. Now you can see 1 mF. Can you see it? 1 mF. And then the bad one and the old one, you can see there's no capacitance inside it. So it's totally dead. And that's why you saw the fan start very slowly. Now this is the problem. So we have to replace this one, and then we can fix the fan after we replace this capacitor, and your fan, my fan will be like a new friend. Increase the solder first, and easy to melt this one out. You can see how easy I am. This is totally dead. This is a totally dead capacitor. You can see here. Now let me check it again. This is the good one. Now you can see 1.003 mF. And this one, you can see 157.2 nanofarad. So it's totally dead. This is why my fan starting very slowly. This is the good one. Okay. Now the problem is here. You can see there's no holder for my capacitor to hold it firmly. So I have to figure out how to hold this capacitor firmly on this assembly. Okay, let me think a while. Now here I can figure out how to fix this capacitor firmly. Here you can see there's no room for here to tie this capacitor up. One method is to drill here, drill a hole here, and then tie it from here and to there. But there's a problem here. Once you drill at this configuration, the iron strips or iron powders will go out to this coil. So I don't want them to drop into this coil. It will damage the motor. So I have to use a little kit here, magnetic. See, a huge magnetic force here. You can see. What I'm going to do is here. I use the paper. Now let me show you how. I put it here. Every powder, drop it to this. It will be attracted to this huge magnetic force. Here you can, if I drill here, and then the residue iron powder will drop here, so it will not damage this coil. Now here I'm trying to drill this hole and this hole. Here, draw a line. For reference. Here. Maybe this drill bit is too big. As we use the smaller one. Now here we use the smaller first. Now you can see here, totally attractive. Now you can see the power of this magnet. Okay, no problem. Yeah, that's all right. You can see here, very clean, very clean. Now you can see how clean this drilling here. And then I put this paper inside out. Now you can see I pull out this magnet and then I drop it to the rubbish. Here, it's very clean magnet. Here you can see the iron powder here. You can see here. It's a very smart method to drill clean here. Then this one, this all rubbish, drop it into the rubbish bin. Now because this hole is very small to fit a large cable through this small hole, I have to enlarge this hole first. Now put a magnet, this magnet, super magnet. Now I'll put it here to attract the iron powder. Okay, and then I'll replace this drill bit bigger for the bigger one. Now here, you can see the iron powder are attracted by the supermagnetic power. Now you can see. Now here I have drilled 2 holes here. It's big enough for a cable tie or a wire to through here. So now here we can put the new capacitor and hold it firmly by these holes. This can wire around it and then tie it up. Okay, here I found a wire to tie this up. Now let me show you, but it's connective if I just use this iron wire. So before I put it to tie the capacitor, I have to put an isolation tip first. This tip can isolate the electrical connection. Here you can see. Here. Now I cut it. I cut it shorter than this plastic wire, so that this connected wire should be totally enclosed by this plastic tube. Now here. Now it's totally immersed into the plastic tube so that it can be disconnected from electrical connection. Now here, this is the most dangerous if we use the only the naked wire. Now here you can see this. Okay, now we close here, now it's firmly, when you see this cut to here, yeah. Now it's very firm. Now you can see here, that's tight. Give it two more rotates here. It's firmly okay. Yes, good. Now you can see it will break down the plastic tube here. This is very sharp, so very sharp. So let me hide this one. This. Now it's totally high the sharp at this point, so that it will harm you in the future. Now if I don't use this plastic tube to hold this iron wire, it will short this terminal, whether one of them, so that it will short to the ground. So it's very dangerous if I don't use this plastic tube. Now I use the plastic tube, it could not short this wire into this terminal to the earth. Yeah, now this is very safe. Now let's get connection to these wires. I have to power up the iron first. So the iron here, this one here is lit up. This. That's okay. Before that, I have bought this shim with temperature. Here it can withstand 135 degrees. Now let me try whether this should. Yes, this one is good. Cut from here. We want 4 of them. 4. Now because this shrink due to high temperature plastic tip, it will protect from electrical connection. If you buy one of them like this one, it will very long, like 1 meter long. However, 1 meter long, you can hardly to store them at home. So I have to cut them all to put it together. So each time we use just a little bit. So this is a very cleanly and tidy method and techniques to use. You can try this at your home. Now here you have to check regularly to this wire, whether your fan is disconnected from the main power or the main grid. This is the electrical safety. Otherwise, you will get electrical shock. You will dead by this one. Yeah. Now you can see black and white are grouped together, and this purple just one wire connected to this terminal. We can tie it to one terminal together, or we can separately tie them up, because this terminal is connected internally, so it doesn't matter for me to tie this up or separate. Here, this is hit up and see how. No. Now I would like to separate them one by one. It's easier for me to solder them up. Now here. Remember, before you solder, you have to put this isolation tube put in the wire first. Now be careful, your lid drop into this coil will damage this coil. So first you have to use paper to block the dropping down to the coil. Here you can see this is the techniques I use very often. Now after I do this, it will clean all the redundant lid. Now here I have hooked them up to the hole, and so that I can easily to solder them up. You can see here. Now, very good, very good. Now I put a little bit lid to my iron. This is because it will be ionized next time if I don't put this to this iron tip. So this is a good technique to protect this iron heater. Next time I want to heat up, and then I drop this one, and then I have a clean tip for next time use here. Now before we have put this isolation plastic into, now here we can measure the capacitance to see what happened to this, because it has been connected to the motor coil, so we cannot measure the capacitance anymore. Now let me check. Now see, we cannot measure, but actually it is 1 mil F. Let's measure the resistance. We would measure some resistance between these two terminals because we have to connect to the coil in parallel or in series. We have to check the connection diagram, but I don't. Let's check. Now you can see 1.26 kilo ohms between two terminals. Now here, before we go further, we have to check the fan, whether it starts normally, whether it starts quickly and normally. We have to put into the main power before we go next step, but you have to be careful that this will cause electrical shock. So after you have to test, you have to pull this out or switch off this pot. Here. Now you can see I fixed the fan. It starts normally and quickly. So this fan is very good fan. Now you can hear the speed of the fan. Now that's very good repairing today. I'm teaching you very good techniques and other usable methods. Here I just test my fan. It runs normally and fast. So we go to next step by pulling out this shortcut for safety issue. So now we have pulled it out, and we should test whether there is electrical between two terminals or anything there. So this is safety issue. Now we have definitely make sure have pull it out, so I can do it by hand. Now here. It's a bit difficult to put it in position. Yeah. Now this one we should close it also, because as I told you before, this is connected to this terminal internally. So if wire have electric, it will go through internal, and then here it's very dangerous. So I have to use other plastic tape to close it up. Oops. Oh, it's gone. Never mind. I have many of this. Now hold it and then cut it. It will not run it again. Here. That's very safe. Now here, this is the high temperature shrinking tube. So I use a fire to put them shrink together. Now here, this high temperature shrinking tube, if you like, I name it. I forget what is the professional name here. Now I use a fire to shrink them up. Now let's look. Use it quickly, otherwise it will melt. The plastic tip will melt, or the wire will melt. Now here it's very good. It's a very good quality. Here you can see. Now you can see it's a good quality, shrink together. So yeah. Well, it's a good fan now. It's just like a new fan as I just bought it 3 years ago or 5 years ago. I don't remember. So yeah, that's all. Thank you, guys.